We've all seen those incredible videos, right? Volcanoes just absolutely erupting, pouring these rivers of molten rock all over the place. I mean, it is one of the most powerful and, frankly, awesome forces on our planet. But have you ever stopped to think, where does all that stuff actually come from? And if the Earth is constantly spitting it out, are we, hollowing ourselves out?
Well, this exact question was posted online, and honestly, it's a fantastic question. It's not silly at all. In fact, it's one of those questions that gets right to the very heart of how our planet functions. It's the perfect launchpad to explore the incredible forces that are constantly shaping our world.
And you know what? I could not agree more with this commenter. Asking these big, fundamental questions is literally what science is all about. So let's honor that curiosity and really dig in.
Okay, let's break this down. The original question is really built on two super common and totally logical ideas we have about our planet, and they are definitely worth a closer look.
So first up is the idea that magma is just this fiery liquid from the Earth's core that's bubbling straight up to the surface. Makes sense, right? And the second idea is that this is a one-way street. That material is being lost forever, slowly hollowing out the planet over millions and billions of years. So let's tackle that first assumption. Where does magma really come from?
The answer might not be what you think at all. See, it's not really about the core. It's about a whole different layer of the Earth, the mantle.
And here it is, the first big plot twist. We tend to imagine the Earth's mantle as this giant ocean of sloshing lava. But for the most part, it's not. It's rock. Yeah, it's incredibly hot rock for sure, but it's solid because it is under an absolutely unimaginable amount of pressure.
So, here's the key takeaway. Magma isn't coming from the Earth's metallic core way down deep. It's what you get when you melt the rock from the upper part of the mantle, or even from the crust itself. Geologically speaking, it's a pretty shallow thing.
Which, of course, brings us to the next perfectly logical question. If the mantle is solid rock, how in the world do we get these massive amounts of molten magma from it? Well, it turns out you don't always have to just crank up the heat.
It turns out geologists have figured out there are three main recipes for making magma. You can think of them as three different geological tricks for turning solid, super hot rock into a liquid.
Okay, so take a look at these diagrams here. See that red curve? That's kind of the magic line, the melting point. Now on the left, that dot is a piece of rock deep in the Earth. It's super hot, but the pressure is keeping it solid. But we can get that rock to cross over the line into the liquid zone in a couple of really clever ways.
Recipe number one is all about taking the pressure off. Literally. Imagine a chunk of rock deep in the mantle. It's hot enough to melt, but the crushing weight from above is squeezing its atoms together, forcing it to stay solid. But if that hot rock starts to rise, the pressure drops. One commenter had a perfect analogy. It's like boiling water on top of Mount Everest. Because the air pressure is lower, water boils at a lower temperature. It's the exact same idea here. Reduce the pressure, and that already super hot rock can finally melt.
Now, the second method is kind of like a chemical magic trick. If you add water and some other gases, what geologists call volatiles, it actually lowers the melting point of the rock. It's just like how we use salt to melt ice on a frozen road in the winter. The salt doesn't make the ice hotter, right? It just allows it to turn into water at a much colder temperature. Well, adding a little water to hot mantle rock does the same thing. It's a fantastic bit of planetary chemistry.
And the third recipe is the most straightforward one, the one that probably makes the most intuitive sense. You just add more heat. Just like this diagram shows, when a blob of hot magma rises up from the mantle and gets stuck in the cooler crust, it acts like a furnace. It just sits there and literally cooks the rock around it until that rock melts, creating a whole new batch of magma. And what's so cool is that these different recipes create totally different kinds of magma. At one end of the spectrum, you've got mafic magma. It's super hot and really runny. Think of ketchup. This is the stuff that builds those huge, gently sloping shield volcanoes like you see in Hawaii. But on the other end, you have felsic magma. It's much cooler, it has a lot more silica in it, and it is incredibly thick and sticky, kind of like thick, cool honey. And that stickiness is key because it traps gas, building up insane amounts of pressure that can lead to those really explosive eruptions, like Mount St. Helens.
So, we've cracked the first mystery. Magma is born in the crust and the upper mantle. But that brings us right back to the second part of that original question. Even if it's not coming from the core, are we still hollowing out the planet?
And the answer to that is a huge, definitive no. The Earth isn't like some piggy bank that we're slowly draining. It is a closed system. It's constantly remaking and recycling itself through the absolutely amazing process of plate tectonics.
This process here, it's called subduction, and it's basically the planet's own recycling plan. You have a dense, oceanic plate that dives back down into the hot mantle. As it sinks deeper, all that heat and pressure squeezes out water that was trapped in the rock. That water then rises up into the hot mantle rock right above it, and what happens when you add water to hot rock? Boom! You get flux melting, a recipe number 2. This creates brand new magma that then rises to feed volcanoes.
This analogy from that same online discussion is it's perfect. The rock cycle is just like the water cycle. Rock is created at the surface, it travels across the planet for millions of years, and then it gets pulled back down into the mantle to be melted and reborn as something new. It is a beautiful, self-sustaining loop.
So let's trace the final steps of this whole journey. Once that magma is created, it starts its slow, buoyant rise up through the crust. But, not all of it actually makes it to the surface.
Some of this magma gets trapped and cools down and solidifies deep underground over thousands, even millions of years. This super slow cooling lets big crystals form, creating what we call intrusive rocks, like the granite you might have as a countertop in your kitchen. But the magma that does make it all the way to the surface erupts as lava. It cools really fast in the air or water, which means it forms extrusive rocks with tiny little crystals like basalt or rhyolite. And that new rock forms brand new crust, setting the entire planetary cycle in motion all over again.
So, there you have it. A simple, honest question about volcanoes opens up this incredible story about how we live on a dynamic, living, breathing planet. The rock cycle is the engine that has shaped our continents, our oceans, and our atmosphere for billions of years, and it is not stopping anytime soon. Which really just leaves one big question. What's it going to build next?